I've had a couple different laser engravers over the last few years. I wouldn't call myself an expert. I'd say that I dabble. I just got this Creality Falcon 2 22 watt diode, and of all the 6 lasers I've had so far, this one's my favorite. To start with, from opening the box to turning it on, fully set up, took less than 10 minutes. So if you're a beginner or just getting into the diode laser thing, I highly recommend this machine, and in this video I'm going to show you how to set it up and start using it. Unlike some of the other lasers I've used in the past, this one actually comes with adjustable feet. Not that there's anything really wrong with putting blocks underneath the laser or elevated above the engraving bed, but this is much nicer and more robust. What's also nice is that the belts come pre-installed, and the eccentric nuts were perfectly adjusted right out of the box. What's also pretty cool is that the air assist is fully integrated into the CPU of the laser itself. So what I mean about this is that the pump will turn on and off as needed and directed by the laser rather than the user having to remember to turn it on. The module itself installs incredibly easily. You just slide it on and tighten down 2 thumb screws. But what I like the most about the Falcon 2 is that all the cable management is top-notch. It's integrated into the machine, including the air assist tubes. The connections are robust and don't seem like they'd be prone to breaking. So one thing I want to add too is if you're new to the laser engraving scene or cutting, you really want to get one of these honeycomb cutting mats. It protects your work surface as well as helping with things like actual cutting through plywood and stuff like that. They're really essential. The computer connects with a USB-C, which is really nice to see that Creality is using more up-to-date technology than what a lot of other lasers use. So here's a common and silly mistake sometimes people make. You plug in your new laser, you turn it on, and nothing happens. Well, this model has a keyed lockout, so first off, make sure that's turned on. And the Falcon, like a lot of tabletop engravers, has an emergency stop button, so make sure it's released. This has an auto home, which is really nice because you always know where the laser is going to start at. You can also make minor jogging movements through the control panel. The laser module itself has some warning lights, and I didn't realize this at first, but after the machine's been on for about a minute and it's not in use, it will go to sleep, and when that happens, the air assist pump goes off and the air warning light comes on. This is normal. You can also operate the machine by saving a G-code onto this little TIFF card through the supplied USB adapter, and I'm not going to really get into how to do that because I think it's much better and easier to operate through Lightburn, which is what I'll show later. Beam focus is done using this little setup block, and it's a stepped piece of metal that you use by putting underneath the laser head and whatever it is you're engraving on or cutting depending on what you're doing. So it's super simple to use. You just put it underneath the laser, lower it down, tighten up the thumb screws, and you're good to go. On the supplied USB drive are a number of files that can help you with this, including software. So I'm going to show how to connect this laser using Lightburn, which is a $60 program that if you want updates, you can renew at $30 a year. You could also run the machine using Laser GRBL, which is free. Anyway, with the laser connected to the computer, you open up Lightburn and go down to Devices. Now I thought initially I'd try Find My Laser. It did not find it. And I would not be concerned about this because I've never seen Lightburn actually find the laser. So instead we'll do Create Manually, which is a really easy process. So click Create Manually, and then what we'll be selecting is GRBL. After selecting, click Next. We're connecting the laser to the computer via USB, so we'll select that and click Next. So this is the second laser profile on my computer, and it needs a name, so I'll call it Falcon 20 watt. Then we need to put in the dimensions that the machine can operate in, and on this it is 400 by 415 millimeters. We have to set the origin for the auto home, which on this is at the front left. Then we click Finish. Now make sure before you're actually trying to connect to the machine that you turn it on. So with the machine running, I'm going to go down by next to Devices, hit that drop down, and I'm taking COM 7, which is the virtual COM port that Windows is using to connect to the laser. Then just to make sure it's operating, I'm going to use the box tool, make a simple box, and click Frame. As you can see, the laser is moving, so it is definitely connected. So I didn't need to update the firmware, but I saw in a few forums questions on how to do it, so I thought I would include the process. It was super easy to do. I just Google searched for Creality's firmware site and found that pretty quickly, but here's the URL if you need it. So you just navigate through to the laser engraving machine firmware. So I'm going to select laser engraving machine firmware, then I'm going to go to the Falcon 2, and mine is the 22 watt, so that is the link I will click to download. I'm going to go to my downloads after it's complete, which goes really quick, and I'm going to open up that folder and then select the 22 watt release. So I need to save this file onto the TIFF card that the machine came with. And to do that, I'm going to use the USB adapter I showed earlier. So this also came with this USB-C to USB adapter, and that is what we use to put the firmware actually onto the machine. So with all the adapters and the firmware on the TIFF card, you stick it in the little USB slot on top of the laser module itself, then turn the machine on. The warning lights flash like so as the firmware is installed. Now, my air light did not immediately go green because I've been playing around with it a little bit and realized I forgot to reconnect the tube to the machine. As soon as I did, the light went green. So anyway, installing the firmware is that easy. So for my first use, I wanted to run a Lightburn file that I had already created. I opened up a channel logo file that I had used for part of the magnetic lock secret compartment videos about a year ago. Link in the upper right hand corner. So here's a trick that makes things a lot easier when you're setting up your machine. Go to device settings and then enable laser fire button, and if you want, click laser on when framing. Next you go over to the move tab and you're going to set the laser power to something really low. I use 3%. So what these steps do is it will make it so the laser will come on while you're framing so you can see where the beam's actually going to hit your material. Now when you click frame, the laser will come on at a really low power setting. If you didn't select laser on while framing, you do need to hold the shift key when you click the frame button. Anyway, this can really help line up what it is you're trying to engrave. And if you really want to get this accurate, you can add a camera to your machine, but that is not going to be part of this video. One other thing I like to do when I'm setting up a new laser in Lightburn is go to device settings, go to the additional settings tab, and then click read from controller. This replaces presets with what your laser is actually capable of, and that gives you more accurate engraving timings. So anyway, before doing my engraving, I remembered to set the beam focus using the little setup block I showed earlier. So what you're not seeing is behind me there's a fan and there's an open window on the other side of the engraver, and all that wind from the fan is making my thin piece of plywood move around a little bit. I definitely don't want it moving around during the engraving, so I'm using these little magnets to hold it in place. I'll put a link to them in the description of this video. Once I'd secured the plywood, I clicked frame one more time to make sure that the laser wouldn't hit those little clips. Luckily they were low enough, so I went ahead and started the engraving. Now most of the playback in this video is at either twice or sometimes as high as 6 times speed, however not these shots. This is all running at real time. Now this machine is capable of up to 25,000 millimeters a minute, which is very fast for a diode laser, but most of the time you'll be cutting it a lot slower. How deep an engraving or cut will go is a direct relationship between the amount of power going to the laser and the amount of speed that's being used. So even that little bit of engraving created a fair amount of smoke, and it being January, I didn't really want to keep the window wide open with a fan blowing the entire time. I've had this collapsible enclosure and I thought it was time to try it out. Obviously this is made by Creality, but there are tons of these available online, different manufacturers and whatnot. They all work kind of the same though. The idea is simple. Put some sort of enclosure over the laser and then duct the smoke out. Now you always want to use a laser engraver in some kind of really well ventilated place, and even so having an enclosure like this is a good idea. Anyway, with this assembled and the exhaust duct now running out the far less wide open window, I decided to run a materials test. This is a feature built into Lightburn and it really helps you dial in whatever kind of settings you need for whatever material it is you're trying to engrave. For my first test, I'm just throwing out some basic parameters, including the minimum and maximum speeds and minimum and maximum powers. What you'll see here in a second is a basic grid work which will illustrate how much power versus how much speed an engraving will take. Ideally, you don't want to be running the laser at more than 80% power on any sort of regular basis because that will help prolong the life of the laser module itself. Even within the materials test, you can still check framing. It looked like I had enough space, so I decided to increase my test to 20 by 20. You can also change the size of the test squares. For this one, I'm running it at 5mm by 5mm. Now, just for a heads up, this piece of plywood I'm using is really low quality. And as will become apparent in a minute, the max power I'm using is way more than is necessary to engrave this. So with the enclosure sealed up, I went ahead and hit start. The materials test will start by engraving the X and Y axis, showing what the power and settings were. This is really nice for later on when you're trying to identify the best speed and power settings for whatever material you're trying to engrave is. So I let this run for a few minutes, but then I aborted it when I realized I had wildly underestimated the power of the laser. Now, I suspect that there was a void underneath some of the layers of this plywood. However, as you can see, it still went almost 3/4 of the way through. Now, even though that enclosure worked pretty well, I have a much better one. So in a very recent video, I built this laser enclosure. Aside from any obvious reasons why you might want to enclose your laser, I also made this one so I could film in it. If you want to see the video on how it was made, click the link in the upper right hand corner. Anyway, I did have to make a small modification so I could get the air assist cord in. Because the connectors come straight out and I hadn't designed this enclosure specifically for this machine, I had to add this little hole. I did dress it up though with a little 3D printed fairlead. With that minor issue solved, I went back to materials tests. Now that I had a better idea of what this laser could do, I tightened up my mins and maxes. I made my test squares bigger. I increased my minimum speed and my maximum speed to the machine's stated maximum of 25,000, and I decreased my max power. These settings seem to be a lot more spot on for something like plywood. So I closed up the enclosure and started the actual engraving. This took about an hour to run, and some of this is filmed in time lapse. I let the laser do its thing while I took care of other stuff in the shop. Even though this machine has a number of sensors and alarms on it, you really shouldn't let a laser engraving machine run unattended. This materials test gave me a lot more useful data if I was trying to identify what settings I would want to engrave plywood. Now, diode laser engraving machines, and it really doesn't matter which manufacturer, are best suited for things like wood, leather, paper, some plastics. They really won't mark metal well, if at all. However, there is an exception. Stainless steel is one metal that you can mark with a diode laser, and some interesting things happen when you do this to stainless steel. Depending on the speed and power, you can produce actual colors. That was my first stainless materials test, and I decided to change the parameters a little bit as you see here and run it again. Now, I should have changed the text settings so the scales for this test would actually be visible, but it slipped my mind. Mostly I just wanted to get an idea of what kind of colors I could produce on this stainless steel. Because of reflections, I was having a hard time getting decent photos of this, but this was pretty neat. Now let's say what I wanted to do right now was cut plywood. I'd go back to my materials test, but I would edit the materials setting. You'd change the mode from fill to line. Now the machine will only outline the boxes, and if the speed and power is enough, cut all the way through. I ran my first cutting test on a piece of cherry hardwood that was about 1/8 of an inch thick. I had the air assist turned all the way up, which is important so it gets smoke out of the way from the cut. Here you can see if I run at about 200 millimeters per minute at 50 or 60%, I can get a good reliable cut. Mostly what I use these machines for is making templates for my router out of 5mm plywood, and I found I had no problem cutting that at 500 millimeters per second at 80%. I did a very basic test on some 1/2-inch plywood, and unsurprisingly it didn't go all the way through. I cut the piece in half just to see what the penetration was. It was pretty good, but to be honest, this is just not the right type of tool to cut stuff this thick. Now, if you need to engrave or cut these types of materials, you're better off using a fiber laser, a CNC mill, or a water jet. Alright, so I'm going to try and make this compass rose using a marquetry technique. I started by cutting out some 1/8 inch thick veneers out of 4 different types of wood. I drafted this and imported it into Lightburn as a line drawing, and I want to show you what would happen if the mode isn't set to line. If it's left on fill, you can see here in the preview that it will basically engrave a giant black box. If we set the mode back to line, which is what we want for cutting, and then go to preview, you can see here that it will only have the laser fire where the lines are. And I know from testing that the speed of 300 millimeters per minute with a 75% power on the laser is perfect for the thickness of the wood I'm using. So right now I'm basically cutting out this entire design in one go, even though the only part of this I'm actually going to use is the outside piece. So the reason I'm doing it this way is because I'm still learning how to create vector drawings with the software I have on hand, and that has led to a few inefficiencies. Now, the first time I did this, I noticed a problem right away. My cut line was very wide. I figured this was a beam focus issue, and I wanted to run a quick test before I continued with the compass rose. I threw together this little depth gauge with layers of 2mm thick plywood that I had left over from a different project. I ran test cuts between 2mm up to 14mm in height and compared the results. I measured these with a feeler gauge to determine which laser height gave me the narrowest cut line. It turned out the best height for cutting wood of this thickness was right between 8 and 10mm. Alright, so this is a different Lightburn file where I basically isolated all the different elements of the compass rose, and I decided to increase them all by 1% to help make up any more gap that the beam would leave. If you try to do this in Lightburn, make sure that little lock is set to locked, otherwise the X and Y axes won't increase, it'll just be one or the other. Anyway, so like I said, I made this different file of all the different elements of this compass rose, and I don't want to cut them all at once, so I need to assign them to different layers. Down here, these colored boxes are layers that you can assign to different groupings. What you do is you select the group you want and you click the layer, and then you can make it line, fill, use different power and speeds, more pass counts if you want. It's pretty slick. So right now I'm getting ready to cut out the letters for the cardinal directions. Once those are cut out, I can move on to cutting out the triangles. I turn off the black layer and turn on the blue layer. Doing all the different pieces individually is nice because it allows me to reorient the wood to have the grain direction going the right way. Once I had all the pieces cut out, I started putting them together like a puzzle. I had this idea to put all the pieces down on a big upside down sheet of masking paper so they wouldn't move around too much, but this proved to be more trouble than it was worth. I got a pretty decent fit with all the pieces, and overall, so far I'm fairly happy with the results, but I think that this method needs a little more refining before I would call it perfected. So here's the compass rose pre-glue up, and here's all the waste maple, cherry, white oak, and walnut. I covered the top in masking tape and then flipped it over, applied PVA glue, spread it really evenly, and then clamped it all together. And by clamping I mean I put a bunch of weight on top of it. After the glue had fully dried, I peeled off all the masking tape and then ran the entire thing through my drum sander twice at 80 grit. This was followed by some more hand sanding, taking it all the way up to 180 grit, and then I put on a layer of BLO just to kind of get an idea of what it would all look like. This was just a test piece, but it came out pretty good, and I think I might use it for the lid of a box. Now, for the sake of making an informative video, I was trying to engrave this piece of brass to prove that a diode laser couldn't do it when I had a better thing come up to demonstrate. The lens alarm went off, letting me know that I needed to clean it. This turned out to be super easy. I turned off the machine and then took the laser module off and unscrewed the lens cover. I used the supplied lens cleaning cloth and I wrapped it around a dry Q-tip so I could get it in there. Now there's a little sensor at the bottom of this that's probably used for flame detection as well as knowing when the laser lens itself needs to be cleaned, and I got the Q-tip wet with some denatured alcohol and then cleaned that off too. As long as I had it off, I cleaned off the lens cover / air assist nozzle and screwed it back on. So with everything put back together, I turned the machine on and then I got this error. As it turns out, there's this little reset button you need to press at the top to make that alarm go away. Anyway, I hope you found this video informative, and if you're new to laser engraving, my best piece of advice to you is to play around with the settings in Lightburn and run lots of tests. Thanks for watching.